Bismillah. Bismillah. Okay, question number one. Define the movement. What is the definition of movement? Please don't say turning a fetter. That is correct. But always say it is the force multiplied. It is the force multiplied by the perpendicular distance between the pivot and line of. Is that clear?
Yes, sir.
Yes, sir.
Okay. Just let me share the screen with you. Okay, beta. Now in the next part, it says state an expression in terms of are the torque of the couple due to this. That will be done in the next part. I'm going to do this question number two. The friction between the disc and the pin is negligible. Determine the angle theta. State the magnitude of the force of the pin on the disc. So first of all, we have to find this angle theta. How we are going to do that? So let me. It was already there. Why it is asking me to download? Yes, it is there. Okay. Okay, beta. I hope you can see that clear, right? So we have to find this angle theta. Hassan, can you see this?
Yes, sir.
Sarosh. Okay, beta. In movement, what is our basic principle? The clockwise movement is equal to the
Anti-clockwise.
anti-clockwise. So please, can you suggest? Do you find any clockwise force there? The pivot is O.
6 newtons can is going in the other direction, so 6
So
sine theta will cause an anti-clockwise motion.
I am asking about, do you see any clockwise force there?
Yes, sir. 1.2.
Yes, but 1.2 are two equal and opposite forces.
1.2 from A.
So it means they form a couple. Two equal and opposite forces form a couple.
Couple.
So here, what is the formula for the moment of couple? It is one of the force. What distance is taken in the couple? The distance between the forces, perpendicular distance between the forces. That will be 2 times R, right?
Yes, sir.
Clear? And the force 6 is making is creating an anti-clockwise movement, and it's making some angle. And whenever there is an angle involved, we use formula Fr times sine theta, right? Clear? So here F for anti-clockwise movement, the force F is 6, and what is its distance from the pivot? Is R over 2, and angle is sine of theta. Right, Hassan?
Yes, sir.
Firoz, is it fine? So, beta, this R will be cancelled by this R. Now, rest you can do. What do you think? This divided by 3, 0.4, 0.8, it comes. I guess so. Better do calculation, but I guess so this will be the answer. And
So it
sine
must be
inverse can
3.2
be
degrees.
taken off. So I hope it's clear. What do you think, Suroj? Is it clear?
Yes, it's very clear.
Okay, that's good. Now we are moving. So I hope this one is clear. Should we move to the next part?
Yes, sir.
So it says state the magnitude of force on the pin on the disc. So beta, who was applying this 6 Newton? Can we see the statement? A force F at an angle between the horizontal x on the midpoint. It's not saying anything. Beta, the force will again be the same. The force which the disc will apply on the pin will be same. The pin will be applying on the disc. So here the pin is holding the disc now. Here the pin is applying a force and this pin is holding the disc, not letting it move. It means the force which pin applies on the disc will be same as the disc will be applying on the pin. So force again will be equal to the 6 Newton, right? It is Newton's third law. Clear, beta?
Yes, sir.
No calculation was required. Now, any other question of your choice? Can we do this question? What do you think? Okay. So a spring is there and it's a squarish, cubic object. Yes, it is a cube, right? The cube is initially held so the spring has zero extension. But it is held so there is zero extension and the density of the water is given. It is inside and 7 centimeter deep it is. The cube has a weight and length and the cube is releasing. The cube reaches equilibrium. This is important. And it says equilibrium, it means the upward and downward forces are equal. They are balanced. So let us say, so calculate the difference in pressure exerted by the water on the bottom face and on the top face of the cube. Beta, how do you find the difference in pressure exerted at bottom? What is the formula for pressure of a liquid? It is rho g.
Rho GH.
So what will be the depth of the surface? This length is 5.1. And out of 7, what is the depth of this top?
1.9.
Very
1.9.
right. So here the, let's say this depth is H1 and that is equal to 1.9 centimeter. And what is the depth of the bottom? That will be 7 centimeter.
7.
So we have to find the difference in pressure. So it will be rho GH2 minus rho GH1. It wasn't it the same we did in the
Yes.
derivation? Okay, but so we can take rho G as common to make it more simpler. What is rho? 1000 given from there. G is 9.81 and H2 is 0.07. H1 is 0.019. Why I have written like that?
Because they were in centimeters and you
Very
converted them
right.
in meters.
Shabash. Beta, can you just note the answer of this difference in pressure? Because it will be required in the next part. G. Can anybody calculate this? You have to write it with. चलिए आगे.
Yes, sir.
Okay. अच्छा बेटा. Now coming to the next part. Says show the upthrust. तो upthrust किसके इक्वल होता है बेटा? We are going back to that part. तो upthrust का फॉर्मूला क्या है कि जो हमने नेट प्रेशर फाइंड किया है, तो प्रेशर इज फोर्स ओवर एरिया, and force, as the net pressure is upward, na, pressure from the bottom is always greater than pressure from the top. So pressure from the bottom is in upward direction. So that force is equal to upthrust. We did it in the derivation. So if we want to find upthrust, we need change in pressure multiplied by area. And keep this in mind. That object is a cubic object. So what is the difference? Change in pressure, we will use the value from here. And the area. Can you tell me the value, beta? The value of change in pressure multiplying these.
Change in pressure was 500 pascals.
Okay. So here you get the up, right? Clear? This Rosh, will it be clear, beta?
Yes.
Okay. Now moving to the next part. It says calculate the force exerted on the spring by the cube when it is in equilibrium in the one. So force exerted on the spring. The force in the spring is called the tension, right? How would you find that?
For
So
the cube to
beta,
be in equilibrium, the force exerted by the spring should be equal to its upthrust.
uh-huh. No,
It
not
should be
really.
equal to the weight.
Let me change. Can we see the forces? Can we see the screen? So
Yes, sir.
there are some forces. One force is the weight of the cube, and there is a force upward which is upthrust, and there is another force applied by the spring that is tension, right? We have to find this tension. So what will be the formula? When an object is equilibrium, it means the total upward force will be equal to the total downward force, weight mg. As we need to find the tension, so for that tension, the upthrust adding will subtract on the other side. So upthrust we have calculated here. What is the weight? The weight is given 4 Newton. Can you see?
Yes.
Yes, sir.
So now 4 Newton minus the answer of this written here. I hope you can solve it now. Will it be clear?
Yes, sir.
Yes, sir.
Okay. Okay. Now, beta, next part. The spring obeys Hooke's law. So this is deformation. We haven't done this Hooke's law as spring course. This is our next chapter. Maybe the next lesson we will do this, right? So we are leaving this part for the time. Uh, uh, mm, just a minute. We have done that in O level. Let's do it on the base of O level. The spring obeys Hooke's law and has spring constant this. Determine the initial height above the water surface. This is 3 marks. This is a serious part. Determine the initial height above the water surface before it was released. The initial height above the water surface of the base of the cube before it was released. This is a good question. Let me tell you. This is the height it is asking. This height he is asking for, right? And let me show on this. This is the height they are asking. So, beta, when the spring has reached to this position, it has got some extension, right? Clear? And as it has gone 7 centimeter below, so let us find the total extension. From total extension, we will subtract this 7 centimeter. The remaining will be height above this. And for that, what we are going to do is we are going to find the extension. How would you find the extension? A over F. F is the force in the spring. That is actually the tension. So we need the answer of tension, please. Uh, Sarosh and company, please solve this value.
Is 1.3.
And that 1.3 now subtracted from 4 will give us 2.7, right? So here the force is the tension force in spring. The force in the spring is tension. So that is 2.7. And what was the spring constant? That was equal to 30, I guess. Can you please tell me the answer?
It's, should it not be F over K?
Very right. Thank you for correcting me, beta. I was making mistake here. Doing in a hurry. Extension is F over K. So force, what is the force here? The force or tension in the spring, it is 2.7. And what is the value of K? It was 30. Please, can you tell me the answer?
0.09.
Please tell me further as well. 0.09 and what? Uh, Sarosh, can you help me? Please tell me the answer of this. 500 multiplied by 0.051 twice in decimal, at least two decimal. Is it exactly 1.3 or 1.3 something?
It is. I think,
आसान आप भी कैलकुलेटर यूज करो बेटा आप भी बताओ साथ में दोनों को
Okay, sir.
क्रॉस चेक हो
1.3005. So can round off
ओके
to
ओके
1.3.
ओके 1.3 is fine then. So can you tell me the answer of this again? So it is exactly 0.09, right? So this is in meters. In centimeter it will be,
9
and
centimeter.
as we have to tell the height of this above, it means the spring has extended by 9 centimeter and gone 7 centimeter below the water. It means initially how much high it was. So the height of the object before releasing will be subtracting that 7 centimeter
Two.
that, and that is 2 in centimeters. Do you understand that, beta?
Yes.
Hassan
Yes.
Rosh, this is the good part, let me tell you. Right?
Yes, sir.
Okay, beta. Let us move to the next. To that, the thrust is this. Upthrust we have calculated. They had told the value of upthrust. I didn't see it. I was doing in a hurry. Okay, height above the cube in the water released from the spring. Determine the initial acceleration. So, what will be the initial acceleration when it will be left? From this situation. So, the initial acceleration will be caused by the weight. And was there any force? Spring has zero extension. It means initially there was no extension, and the only force was moving it downward was this.
So then its acceleration was only caused by gravity.
Yes, that is gravitation. So let us read the statement. Maybe the cube water is released in the water is released from the spring. Okay, the cube in the water is released. Yes, it says now the spring is detached. The spring is detached. So, okay, now let me change it for you. Now, when we deattach the spring, it means there is no spring. Now there will be only two forces. One will be the upthrust, and the other will be the weight. And we use the formula F is equal to ma. What do you mean by the F? Resultant force. So resultant force, as it will go downward, weight is 4 and upthrust is 1.3. So the resultant force will be larger force minus smaller force. What will be the mass of the object? That will be weight divided by the value of g. And now you can find acceleration. Can you? Ji beta, Hassan and Rosh, I'm repeating. When it says you release it from the spring, it means now there will be no spring force by the spring, that is tension. Now there will be no tension. Only two forces, the weight and upthrust, will be acting. Right? Clear? So
Yes,
we
sir.
will have a resultant force that will be weight minus thrust, as weight is larger and mass is weight divided by g. M is equal to W over g. Right? Will it be clear, beta?
Yes,
Yes,
sir.
sir.
Okay. So let us move to sometime when we do try to do it in fast. Now I seem to miss some words that I have to look for that later. Okay, and now it's done. Describe and explain the variation of any acceleration of the cube as it sinks in the water. Beta, when it will be sinking, there will be
It,
another force other than upthrust and weight will be acting on it. Can you mention?
Drag.
Drag, water friction, that will oppose the motion. And the forces which oppose the motion, they always decrease the acceleration. They always,
deceleration.
no deceleration, yes, decrease the acceleration first, right? All the forces which oppose the motion, they actually decrease the acceleration. Will you remember? So,
Yes.
how would we explain? So, as the tube will keep sinking, the water drag will oppose the motion, will add up as a force, and will oppose the motion, and the overall acceleration will be decreased, right? And a time will come when it reaches that constant speed and then acceleration is clear.
Yes, sir.
Yes, sir.
Okay. Uh, let's leave this seems to be a bit simpler. Let's discuss it. To condition of system in equilibrium, the resultant force is zero and the resultant torque is equal to zero or resultant torque zero. You can say as sum of clockwise movement is equal to sum of anti-clockwise, right? Okay, a paraglider of mass this is pulled by the wire. First of all, the direction of wire on the paraglider will be this way. It is pulling it this way. The parachute is pulling it opposite. We will discuss it. Let us see what does it ask. Then we will snip it. The wire makes an angle 25 degrees with horizontal. The P moves in straight line parallel to the surface of water. P is the person. He is moving straight. It means the overall upward and downward forces are being cancelled. That is why it is not moving higher or low. The variation, okay, given. Show that the expression is this at 5. So how would you find that? At 5 seconds, you have to find the expression. In speed time graph, how do you find the expression? You take gradient. And you will take gradient of use for finding gradient. You will take any 2 points. You can take any 2 points from this slanted line, right?
Yes,
Any
sir.
2 points. This one, this one, this one, this one, this one. So you have to find gradient. So it will give you answer. So calculate the total distance move from this to this. How would you find the distance? Area under the,
Area under the graph.
okay. Calculate the change in the kinetic energy from 0 to 7. So what is the formula for kinetic energy? We are haven't done this, but let us discuss on the base of
Kinetic
O
energy
level.
is of mass
And
velocity.
yes, here initial at 0 time, it has a speed of. Can you tell me how much it is? 4.6. You will use formula half mv square. Here the speed is 4.6, and at 7 the speed will be 10. At 7 we need to calculate it. It will be somewhere here 8 point something. So you use this half mv square. Nothing special. The tension in the wire is, this is the part actually we need to do. The tension in the wire at time 5 seconds is 280. Calculate the horizontal motion. For the horizontal motion, it is telling, keep, give this bird's respect. That for horizontal motion, the vertical lift force F supporting P. The vertical lift we have to find. It's going in a straight movement. It means the vertical force will be equal to downward force. The vertical force, there will be a downward force. And let me uh, tell you what is the other force acting? 280 Newton. What is 280 Newton? Tension. Okay, this is going to be a good part. Are you ready?
Yes, sir.
So let's snip it. Okay, beta. So we are having uh, tension. Tension is always away from the object. The tension of the wire is keeping the man, the force is applying in this direction. So this is the direction of tension, right? So it will have two components, one vertical, the other horizontal. And if this is the 25-degree, then this is 25-degree as well, right? So beta ji, this component will be 280 times cos 25-degree, and this will be equal to 285 sine 25-degree. As we have to find the vertical lift, we call it as L. There is another force acting on the person is downward, its weight, mg. So when it is in horizontal movement, it means the total upward force will be equal to total downward force, right?
Yes, sir.
So, so what is the total upward force here is the lift we have to find. And downward force is the weight M95 into G plus the vertical component, downward vertical component of the tension time. Beta, this was a good question. Let me tell you, right? Please note it down as I have to move to the next one. Ji Hassan, Soos, do you understand?
Yes.
Yes, sir.
Okay, beta. Let's move to the next part. Okay, the force are due to the air resistance. This is again the good part. Let's go back. So, beta, as it is moving in the horizontal direction, so the air resistance will be exactly opposite to the movement R. And for how it is moving, can we have any idea? Is it given? Is it accelerating or constant velocity?
because the velocity of the person is
And it
is
is
going up.
saying is some acceleration we have calculated, right? We have calculated some acceleration. Okay, 5 seconds. Can you see similarly? It is also 5 second acceleration. So it means it was accelerating now. So we will use F is equal to ma.
Is equal
So
to-
what is mf? Resultant force. As it moves towards right, it means that this component of tension towards the right will be
Is
greater
larger.
than this R. Very right. So 280 times cos 25 degree is larger, and larger force minus will be equal to ma. And what is the value of m? And acceleration is 1.4. Will you be able to calculate R? Is
Yes, sir.
Rose and Hassan. Good question it was. What do you think? Should we move on?
Yeah.
Okay. I hope question is completed. Yes. And any favorite? Any question of your choice of these questions? It looks a bit rushy. Lots of forces. Let's try. Moment is, don't say turning effect of force. It is force, product of force, and the perpendicular distance between the pivot and the line of force. And uniform metal beam is pivoted. Okay, everything is stored and shown in the diagram as well. Okay, and the beam as well. By taking moment about A. But whenever we say na, about A, the point which is mentioned about after the word about is pivot. So A is to be taken the pivot. So we have to find the tension T and the vertical component of T. And the question is not a larger one. It's not a very good one, but let us try it out. We have to find the value of T that is 0.1. We are taking about A. Whenever we say na, about A, it means the next point mentioned will be the pivot. Right, Hassan and Surosh?
Yes, sir.
Yes.
Okay. So, what is our basic formula, beta? Sum of clockwise is equal to sum of. So we have
Anti-clockwise.
two clockwise forces, 500 and 4,000. So we always multiply it with a perpendicular distance. Can you see here, if this angle is 30, can this angle be 60?
Yes.
Okay. So now we did some practice actually in the previous chapter, in the same chapter. If there is a distance d and there is an angle, then the side adjacent to the angle is hypotenuse times cos theta, and the side opposite is equal to hypotenuse times sine. Now, The clockwise forces are 500, and it will be as 500 is the weight, I guess. So the weight now is in the middle way. It means if the total length is 2.4 meter, 2.8 meter, its half length will be, if this is 2.8 meter, then this will be 1.4 meter. And we need this distance. We need this distance, the perpendicular distance, and that is adjacent. So here the distance is 1.4 times 460 degrees, right? Clear? And
Yes,
sorry,
sir.
it was not plus. We have another, so we keep it in the bracket. We have another clockwise, that is 4,000. And for 4,000, the perpendicular distance, the hypotenuse is 2.8. So it will be 2.8 times 460. And anti-clockwise is the tension. And let me tell you, the tension is making 90-degree here. How would I know this? 30 and 60. The third angle will be 90-degree. So already 2.8 is the perpendicular distance from the pivot. So we multiply T simply with 2 points. Can you now calculate the value of T? Sarosh and Hassan, will you
Yes.
understand?
Yes, sir.
Okay. Now, this chapter is relatively easier than the previous one. What do you think? Vertical
Yes, sir.
component TB of the tension, where the TB is goes from T, the vertical component. So let us move to the diagram. It will have a component like that and the other. So if this is 60, this is 60 as well. So the vertical component TB will be, it is adjacent to the angle, right? The component which is adjacent to the angle is original multiplied by sine or cos.
Cos.
So beta, now we know the tension from here and multiply by cos 60. Hassan, will you understand?
Yes, sir.
Beta. And I guess that can be all for today. What do you think?
Okay, sir.
Any other question would you like to ask?